Little bit about our agenda today. We're going to do an overview of the Leica hardware and scanning technology. We're going to talk about a few use case scenarios and application of scanning and point clouds. We're going to talk about TPM's in-house scanning and modeling services and capabilities. We'll do an overview of some of the analysis tools that you can use in conjunction with point clouds. And we're going to talk a little bit about mesh creation and some use case scenarios with meshes. And at the end, we'll do the really fun stuff. We'll talk about virtual reality applications and using point clouds. And of course, we'll close up with a question and answer. TPM is a Leica scanning reseller. So we sell the actual scanners themselves. We also offer reality capture as a service, both from a scanning point of view and a modeling point of view. Now, for those of you that are in the manufacturing arena, although it's not a part of this webinar today, we also sell Arctic scanners, along with the Geomagic DesignX software that allows us to scan, reverse engineer, and then we can print the 3D parts for you, all three of those as a service. Now we're going to start off talking about laser scanning and the specific scanners that Leica brings to the table. First off, what is laser scanning? I think most of you have probably used a disto or some other distant laser-based distance system where you press a button and it sends out a laser to another surface and it bounces back and it collects that distance for you and shows you what that distance is. Well, think of laser scanning as that kind of technology married with a 360 camera on steroids, because the RTC 360 doesn't capture 1 point when you push a button, it captures 2 million points per second. So these scanners are tremendously fast and capture vast amounts of data. Now, there are more scanners to the Leica scanner lineup than the three we're going to talk about today, but these are the three that are probably about 98% of the people out there are interested in. On the lower end of the spectrum, we've got the BLK 360. Now, some of you may be familiar with the Gen 1 series of the BLK 360. They just recently released the Gen 2 series. Huge difference between the Gen 1 and the Gen 2. The speed is just a night and day difference, and it has Viz technology in it, which we're going to be discussing in great detail when we talk about the RTC. So although we're not going to discuss specifically the workflows of the BLK 360, the workflows that you'll see that we are going to discuss of the RTC 360 are basically the same workflows that you'll get with the BLK. Now, the scanner in the center is the BLK to go, which is a handheld scanner, and it allows you to walk with the scanner and it collects data as you walk. And the one on the right is the RTC 360. Now, several years ago, when TPM was looking to update our scanner to get a faster, more modern scanner for our scanning services, we went out and we looked at all the scanners in the marketplace, and we just fell in love with the RTC 360. In fact, we fell in love with it so much that we became a Leica reseller because we just saw all the potential it brought to the table. Incredible speed, very good range, accuracy is there. Everything, it just brings everything to the table. It's the most complete, fastest scanner of all the scanners that we evaluated, and we evaluated a bunch. So we're real happy to be a Leica reseller, and we also use both the BLK to go and the RTC 360 in our scanning services. All right, now we're going to start talking about the RTC 360 and a piece of viewing software from Leica called TrueView. The RTC 360 is a traditional, tripod-based laser scanner. Super fast. It has HDR photography in conjunction with it. And we can create a complete scan in under 2 minutes. That's the scanning and the photography.
Yeah, the speed on that's very impressive. When I first was starting, it was like 15 minutes for a scan that was like 10,000 points a second or something. It was
Now
not near that speed.
The point cloud you're looking at is a historic church in Columbia, South Carolina that we did some scanning in. The data that you collect is just incredible. Now, one of the most important things about the RTC 360 is the Viz technology that's in it. So when you're out in the field and you're putting together these scans, the Viz technology is just a huge tool. Now, as you see, Lee moving the scanner over on the left, you can see the actual red dot moving. It understands where it is in conjunction with other surfaces around it. Even in an environment like that, on a bridge, there weren't hardly any surfaces. Now, this is what it looks like on the tablet when we're actually doing scans. So we've done our first scan here. Now we're ready to move the scanner so you can see the little red dot moving again into our second scan position. And then we're going to start the scan and then fast forward to the scan being done. And now you can see just a fraction of the data, but enough for you to see the surfaces and understand that these two scans are lined up well together. And with that Viz technology, you are always on right exactly where the two line up with each other. So at this point in time, we simply make a link between the two. And then normally we would just go optimize. But what we're going to do here is we're going to look at that link, and you can see one scan's in one color or the other scan's in the other color, and they do match up super well. So we would typically just go optimize and create link. But back in the old days, it wasn't that easy. Back in the old days, they wouldn't be anywhere in relation to each other, and we'd have to move the scan around. We'd have to move it, say, up and down in 3D to make sure the two lined up with each other. And then we'd go back to plan, and then, it wouldn't be anywhere near it like this one is right where it is. It wouldn't be anywhere near it, and we'd have to drag it around. And not only did we have to move it horizontally, but we typically had to rotate it and get it all lined up. And it was quite a manual process and took time out in the field to do all of that. But with the Viz technology, literally we skip all of that. And they're right there together, and we simply create the link and optimize it, and we're ready to go, saving a ton of time in the field. Now, the photography part of the scanning process takes about a minute, and we're actually in a piece of software called Leica TrueView, and all those red dots you see are actual scan positions, and we can move to those scan positions and see the photography, and you can get an idea of the absolute tremendous amount of data that's there for you. Now, photography is optional. You do not have to use photography. If you don't use photography, it looks something like this. It looks almost like a black and white photo, but it is not black and white photography. It is no photography at all. But this is what a scan would look like if there was no photography. Now, I'm going to talk a little bit more about this TrueView software because this is an absolutely awesome piece of software. You saw that we just took a measurement using the TrueView software. Now, the beauty of the TrueView software is it offers the designer, as they are modeling, tremendous views and the ability to look at everything they need to look at So I typically, if I'm modeling, have TrueView up on one screen and Revit or whatever I'm modeling in on the other screen, so I can kind of move around the point cloud and look at the photography. But the fact that this is a free viewer really makes it a tremendous tool, because not only do the design people who have access to the point cloud through their design software, but other project stakeholders, managers, owners, other people can be given this free viewer and have access to this tremendous amount of important data and be able to take measurements and other really, really useful things. So this TrueViewer is a tremendous tool to bring to the table. Now, next I'm going to talk a little bit about the concepts and how you scan with the BLK2Go. So the BLK2Go, as we said, is a handheld scanner. And as you walk with it, we call it the Statue of Liberty walk. So you're holding with the scanner in front of you as you walk. And the pace that you walk at controls the density of the data that it's capturing. And as you can see right here, we're walking at a pretty good pace, but we're capturing a tremendous amount of data here. So this allows you to capture data just incredibly fast. And we found many use case scenarios for this type of scanner, as well as the more traditional scanner. Now, it uses a technology called SLAM, or simultaneous location and mapping, so that it's looking at its surrounding and understanding its surrounding as you're walking. So as you can see, Lee's taking a walk. On the left-hand side, you see a plan view of what he's seeing on his phone or tablet, whatever he's using. And on the right-hand side, you see a 3D view as he's walking. That tablet or the phone, and we typically use a phone with this one, allows you to see what you're capturing as you're walking with it. Now, this is back in TrueView. So just like in the church, we can do fly-throughs of our point cloud data in TrueView. So we're doing a fly-through right now of the data he captured when he was walking down this path using the BLK2Go. We have found that using these two technologies together can be a very effective tool. There are obvious things that the RTC is the only way to go, but there are many things that the BLK can bring a lot of capabilities to the table. I'll give you a couple use case scenarios, something like a medical facility that's got lots and lots of little rooms. Okay, with an RTC or any other terrestrial scanner, you're going to have to set up in the hall, then you're going to have to set up in the door and do another scan in the door, then you're going to have to do at least one scan in the room. With the BLK2Go, literally you can walk into the room, make a 360 turn around the room and walk out of the room. So, and the time it does, you can do the one scan out in the hall before you even get in the doorway or anything. You've already got the room and have moved on to the next room. So it gives you tremendous capabilities to capture a lot of data really, really quickly. And if you're good with the accuracy it's giving you, which is giving you sub half-inch accuracy, it's a tremendous tool. And when you use it in conjunction with the RTC to give it anchor scans and tie the two together, it improves the accuracy just a little bit. I'll give you one example. We had a big project up in Charlotte that involved a huge food court. Now, obviously, the RTC was the way to go in the food court because it had a super high ceiling, a lot of glass. So the RTC was the obvious choice there. But when we went into all these little restaurants, first off, they weren't real happy with us coming in to begin with. They certainly didn't want us to spend, an hour in their restaurant or a half an hour in their restaurant capturing data. So with the BLK2Go, we were able to capture that data really, really fast and do a walk for each restaurant and then tie it back into the see data that we did out in the food court made a great combination, and that's the kind of project that combining these two technologies is a real win-win situation. Now we're going to talk a little bit about common use cases for point clouds and scanning services. Basically, any project where you have an existing building condition and you want to capture that existing condition, scanning services are what you need. Now, we do a lot of architectural renovations and historic preservation work. That's probably one of our biggest. We also do a lot of work with manufacturing facilities to capture the plant layout, where plans maybe don't exist, or more likely they have a set of plans, but it hasn't been kept up to date, and equipment's been moved around, and things have been added to the plant, and they don't have a complete up to date. So what they can do is come in and scan part of their plant. If they're going to do some kind of changing of equipment in that area, so they can have accurate information. Or sometimes they'll just scan the whole facility if they decide we want to go get an updated plan of our facility. Some people call this digital twinning. So we do a lot of that as well. And think about things like mechanical rooms and process piping, that capturing all those pipes and all that equipment and everything any other way is almost really impossible to do accurately. So those are some of the big applications for point clouds and scanning services. Scott, you want to talk a little bit about scanning in the construction arena?
Yeah, from a construction standpoint, I mean, a lot of the scanning really comes down to, documentation and really helping facilitate design and kind of informed decisions around that. And so there's a ton of use cases that we'll get into here in a little bit that are outside of just kind of the modeling effort, but a lot of those models and the point clouds can be used for a lot of different, analysis and comparisons against each other. To help determine, actions to take or evaluate existing conditions, essentially. So it's a very speedy tool here to get a lot of that, and especially in the construction space, reducing your impact on tenants potentially in a renovation and stuff like that. These point clouds and scannings are huge value adds.
Now, what kinds of things can be captured? First off, just to make sure, I know I talked a little bit about scanning technology, but I didn't say one thing that I need to make sure everybody understands. This is a line of sight technology, so it can't see through walls, okay? So, that's why you capture from multiple positions, to be able to capture everything. So we can capture architectural elements, structural elements, MEP and fire protection, equipment and site elements. Now, if you need us to capture, say, HVAC equipment above ceiling, we do have the capability of doing above ceiling scans as well. So we can capture the full gambit of information. Now, if we were to provide scanning services for you, there are basically 3 different deliveries of our scanning services. The first delivery is a standalone laser scanning service where the deliverable that we end up giving you is the registered point cloud. And it's a part of our services, all the back end combining of the scans and registering them and publishing the point cloud is all included in our services. So the deliverable to you would be a registered point cloud that you can bring into Revit or AutoCAD or whatever package that you're going to be modeling out of. Now, let's say you don't have any modeling expertise in conjunction with point clouds in-house, and you don't know how to use the point cloud in conjunction with modeling the elements. We can give you some training on that and get you started on your journey there. So we can train you on both Revit and AutoCAD and how to bring in point clouds, how to use them, and how to model from them. So, you know, if you're interested in getting that expertise in-house, we can help you there. But by far the biggest deliverable we have is the combination of the registered point cloud and say a Revit model or some other kind of CAD file or CDs or Navisworks or whatever kind of file format. We can produce just about anything that you need. So most of our people end up, you know, say you're an architect, you've got a renovation, you don't have time to do it in-house or the expertise to do it in-house. So basically, when we hand over the point cloud to you, we also hand over a Revit model to you, and you're ready to start, you know, without having to go out in the field and collect any data and do all of that. Tremendous time saver. So number 3 is basically the one that we use the most and get the most. Now, when you're talking about modeling, we're talking about levels of detail, or LOD. So these are some established level of details from the AIA. And this is a little chart that tells you what you get at the different levels of detail for the different disciplines. And when we're talking to you about modeling, we're going to talk to you about what level of detail that you need for each discipline that you're wanting modeled. And the nice thing here is we can split it up and do different levels of detail for different elements depending on what your needs are for a particular project. So maybe architectural, you could do LOD 200, MEP maybe 300, and you have to do some structural analysis. So you really need to get fine detail on the structural. You can bring it up to 350. We can do any combination that you need for your project. So the next thing we're going to do is I'm going to turn it over to Scott here, and he's going to talk a little bit about using point data or point cloud data and the analysis tools. So Scott?
Yeah, so scanning is great. It's easier now than it ever has been, especially with the huge speed increases and the technology just generally improving. It's never been easier, and it's a very versatile solution to help really capture and document any space. There's very few, or I'd say there's not a better documentation technology really, and it allows for that extra level of analysis, and there's quite a few different use cases for that. Bruce mentioned the modeling, which is kind of where everything starts, as mainly this technology with the point clouds and laser scanning will be leveraged throughout various phases of a life cycle, kind of a construction AEC project, where you'll be able to use these in different stages and different forms, and that model is where a lot of that stuff will revolve around. So the point cloud and the model will be used together, but we've got that data. There's a ton of data that comes across in that point cloud that can be used in addition to creating those models. Those models will end up kind of almost simplifying that to a best fit plane and everything else as you create models off of those point clouds. But with those dots collected essentially in that point cloud, there is a lot more that can be done with that. So it's now been easier to get your hands on this technology than it ever has been, and your speed has really increased. So this has a lot of really good use cases in, obviously your renovation projects, but even like hospital situations or scenarios where you want to really avoid disturbing the tenants that are existing to capture that whatever is needed. So kind of one of the first things that we look at when we do the floor or the analysis techniques is the floor flatness heat maps. So there's a few I'll hit on here, and this is one of them with a really good example. So our floor flatness heat map that we can create from this point cloud. So we can compare that against models as well for deviation analysis and making sure that your model versus the point cloud line up. And what we're showing here is really a floor heat map with, you can see the little kind of chart there in the center that shows anything that's red there is greater than 5/8 of an inch, and anything in blue is lower than 5/8 of an inch. So you can see visually very quickly where areas need some attention, and this really comes in handy on making sure that you're able to visualize and make decisions quickly. I've seen this type of an image used to help explain a design issue and a change order related to floating a floor and having a unique situation that we needed to get everyone involved around that, and we had the laser scanning data and threw that into our software here, and we're able to quickly produce a heat map to make some decisions very, very quickly here. So, floor flatness, we're able to take all those point cloud data and compare them and give us this type of an output. There's a few other outputs related to floor flatness that we could get into, but the other one that we look at a lot is the pile volume. This is a lot of time used just generally on balancing a site or looking at what stockpiles volume are available on site. So this point cloud data can be captured with the laser scanning instruments we've talked about here today, but it also can be captured with drone data and reproduced that way as well. So works hand in hand with Civil 3D and a lot of those systems there to create tins essentially to compare against and get you your volumes. So we've got a video here kind of showing how that can be broken apart very quickly with Cyclone and the different kind of reports that can get created out of that. So pretty cool technology there. And kind of on the floor flatness line, as mentioned earlier, with the heat map, there also is a formal ASTM E1155 report that we can produce with this software that will give you a direct floor flatness report based on that data. And you'll see our snapshot over there, the inspection results that come across with that report. In addition to these examples, you're also able to do some deviation analysis. So this is really powerful for, looking at maybe a wall, seeing if it's moved and looking at some structural analysis there and some of the integrity assessments. You're also able to leverage these point clouds into extracting 2D plans and sections, as well as the 3D models that we talked about there. And the sections are really powerful, as Bruce mentioned. We're not able to obviously scan through the walls yet, as much as I'd love for that technology to be there. We're not quite there yet, but we can capture both sides of the wall very quickly, especially if you have some ornate, maybe historic renovation. Some of those sections can be captured very quickly and very detailed. So allows for an additional, kind of 2D view of that data, as well as the, creating surfaces essentially to compare against for the floor flatness and pile process. These models can also be leveraged to look at to create meshes. On that note, let's go to the next slide there, Bruce. Yeah, and so these meshes really simplify a lot of that point cloud data. It really allows for faster processing of that data. So it works obviously clearly in our snapshot very well for unique shapes, but that data can get processed and turned around and leveraged to model, building systems as well. And instead of having an actual model of a pipe, you can have a mesh that we can use in a lot of similar ways as creating that model much faster. So we could leverage that mesh in a clash detection process or in some visualizations, and it really reduces the size of a lot of that information and still retains the accuracy and just provides a general better kind of communication and collaboration tool outside of the point cloud specific kind of deliverable. going on here. We've got kind of a video to show how we captured that airplane. And so this airplane, you know, kind of think of ways that these meshes could be created. You know, if this airplane was being relocated into a aviation museum, it'd be, you know, one thing to have a photo of this, you know, and maybe some measurements that you try to take on the ground, but having this and being able to leverage this in your design and your planning, not only from a design standpoint, from a construction standpoint, has a lot of value there. So yeah, you can kind of see there's some lines that show how it's triangulated and creates that mesh there. So it's pretty cool process, very fast. So it takes a lot of that data and creates a surface, like I said, that can be used very, very similarly as a point cloud there. If we go to the next one, Bruce.
Yeah, we found that in plant layout and mechanical applications, there's a lot of tremendous uses for meshes. A lot of times in plant layout, they may not have accurate current existing conditions. So this is an example of using a mesh. So that piece of equipment or that arm is a mesh, and we're actually moving it around in a point cloud. We're actually using TrueView to do that as well. So we're moving it around in a point cloud. So you can look at optimization of equipment, moving it around and doing those kinds of scenarios, whether you've modeled the plant or not. Now, obviously, if you've modeled the plant, either in Revit or AutoCAD, this mesh could be brought in there and we could move them around and do a similar thing to what I'm doing right here in the point cloud. Now, we've also found that in the mechanical world, there are things like, for instance, another product we sell, SolidWorks. SolidWorks notoriously hates point clouds. I mean, it can bring in point clouds, but if you expect it to work very well with a point cloud, you're mistaken. It'll just overwhelm it and just bring it to its knees. So in that kind of scenario, maybe I'm using this in conjunction with some other kind of conveyor that I'm designing. So what I can do is have a mesh of this piece of equipment and bring it into SolidWorks and design my conveyor and see how the two are going to fit together and work together. So using this in conjunction with my SolidWorks or any other kind of modeling application in the mechanical arena, a great way to use it. Now, as I mentioned earlier, if you're trying to do, reverse design stuff, probably you're going to want to use the Artec scanner for that, and we also provide that as a service, and we sell them as well. It depends on the size of the part, obviously, but with the Artec, you can get sub-millimeter accuracy, which is what you need for reverse engineering tiny parts. So in the mechanical application, there's lots of uses for meshes, and in plant layouts, there are lots of uses for meshes as well. Anything you want to add in your world, Scott?
Yeah, just from the meshes and point cloud continued uses, especially for layout, that kind of reminded me there. We've used this. I use this in the construction space for ensuring that we had our sleeve, locations in the correct spot pre-pour. So we were able to evaluate, making sure that the as-built condition will match the as-designed condition, and really was able to, do a lot of that deeper dive and making sure that everything was going to be able to be planned, very, and built that according to plan, very similar to what you would want to be doing in this kind of a plant layout. So there's a lot of really good use cases for this type of scanning data. It's really good for documentation, and just once you have that data, there's so much that you can do from a modeling
and a mesh standpoint that really revolve around that BDC and BIM kind of workflow. So on that note, there is more. The virtual reality side of this too with the technology is really, really growing. You're going to be seeing more VR integrations with modeling softwares. Just as it becomes more mainstream, units are a lot cheaper now than what they used to be, and there's more and more integrations that make it easier to use. So some of the benefits of having virtual reality leveraged with these point clouds and with these models is it really helps enhance collaboration. It really allows for someone to really evaluate a space. They're able to visually see it as if they were standing there, and really help make informed decisions much quicker. This virtual reality allows for that point cloud exploration and analysis where you can visually fly around and align models to walls, and you can kind of see where things may have been out of place and just kind of plan accordingly there and really make informed decisions. You can use it also for safety and training, help get someone familiar with the job site or a building they're about to be going into. And one of the newer things that we're excited to talk about and even get more into ourselves is the new twin motion integration with Revit. And Bruce, are you able to kind of expand on how that exactly works now with that for everyone who's got a Revit license?
Yeah, Autodesk has gotten into a partnership with Twinmotion, and anyone that has either standalone Revit or Revit in conjunction with one of the collections now has access to the Twinmotion software. And a little bit later on, we're going to show you a video created by bringing in a point cloud in Twinmotion. So great stuff. And most of the Autodesk customers out there have access to this now.
Yeah, great. Thanks, Bruce. Yeah, and kind of from a streamlined design and review and evaluation standpoint, this really can be leveraged in a lot of unique ways, especially in the AEC space. We're able to, do virtual mock-ups, essentially. You could do, a virtual mock-up of a hospital operating room and have people walk in that space and actually make big decisions early on, well before needing to, physically walk that space. So it's a really, really cool tool that can be used in a lot of ways to really help, tell a story and, get good collaboration. If we go on to the next slide here, Bruce, we got a virtual reality and TrueView now. So, a lot of the technologies that a lot of the value that I was talking about there is already starting to get even easier to access with TrueView having a virtual reality direct link. So they're able to view both the scan photos there, essentially, and the point cloud. So it's very, very cool use case where you could really immerse someone in an area that could be on the other side of the globe. So if you maybe even have a unique consultant that wants to see something, this would be a very, very cool tool to help in that regard. Go to the next one here. This shows some of the twin motion capability. This has pulled in the point cloud as well. So you're also able to, not only jump into virtual reality and view this space, kind of like a gaming engine where it's highly rendered, but you can also render out of this, and it works with both the model and the point cloud. So this really, can be leveraged to help tell that story, influence design decisions, and make decisions faster. Helps preserve, unique sites, unique areas, and just really enhance that quality control. So the rendering capabilities in Twinmotion are pretty incredible. Having that in Revit is going to be a very valuable.
I think it's pretty cool that you can add the people walking around in it, and lots of other visual effects off the water and reflections and stuff like that. So it's a really powerful tool. If any of you Revit users haven't tried playing with Twinmotion, since you have it now, I highly recommend you playing with a great piece of software.
Yep. And some of that might look familiar for some of y'all. That's downtown Greenville.
All right. Well, thank all of you very much for attending. Here at TPM, we would love to partner with you and help you on any of your needs in the scanning arena. Just let us know if there's anything we can do for you. If you've got a project that you think you could benefit from this, please contact your salesperson or contact TPM directly. We'll be happy to work with you. We're happy to give you a quote so you can kind of get the feel for what it would look like in your environment. And these days, clients are very, very willing to spend that extra money to get this level of data. So we'd love to work with you on this on any of your existing or future projects.